Okay, class, so I forgot that I never posted the solution for this. So I'm going to put this up so you can see how I did it, and you should also be getting your homeworks back in email tonight. So what I asked you to do is we have a cul-de-sac, which is basically a court, and we have a bunch of properties around there. 6 properties are the same, 2 are the same, and then 7 and 8 are the same, and then 9 is different. And I want to find out how many leaching pools do we need in total for this. So we're not doing it on a per property basis, it's just the total number in here. So when we look at this, we got to break it down to a couple different areas. We have basins properties 1 through 6, properties 7 through 8, property 9, and then the road, which a lot of people forgot on the homework. Got to be careful about that. So in terms of the areas, we have what we would call the total area. We have landscape, and then we have the house / driveway. So for properties 1 through 6, it was 20,000 square feet. And of that, we were given, 5,000 square feet for the house and driveway, which means the landscaping is going to be 15,000 square feet. Then for properties 7 through 8, those lots are 45,000 square feet. And the landscaping on that is 7,000. So 45,000 minus 7,000 is 38,000 square feet. And then for property 9, we have a 60,000 square foot lot, and the house on that is going to be 8,000 square feet, which leaves us with 52,000 square feet. 52,000 square feet. And then our road finishes out with 18,000 square feet. Okay, so now with those different areas, we have to break out what the total volume of water that's going to be created out of that. And for that, we use the formula Q is equal to CIA. For the runoff coefficient, for landscaped area, and this is where it's really important, you have to read. In the homework folder for class 22, there's a Town of Brookhaven document that will guide you on your C values. So when you go to that folder, you get the Town of Brookhaven standards, which means you have to open it up and you have to read. You have to be willing to do this, because in that it gives you exactly what your drainage design criteria is. It says for roofs, you're going to use 1. For roads, you're going to use 1. And for landscaped woodland areas, you're going to use 0.15. So that's what we're going to use for your runoff coefficients, 0.15 on those. So now what I'm going to do is I'm going to look at lots 1 through 6. Q will be equal to CIA 0.15, this is for the landscape, times 15,000 square feet times 5 over 12 to convert over to inches. So 0.15 times 15,000 times 5 over 12. That gives me 937.5 cubic feet. Then I'm going to find out for my hardscape, Q is equal to 1.0 times my driveway, 5,000 square feet, times 5 over 12. 5,000 times 5 over 12 is 2,083.3 cubic feet, plus the 937.5, and that gives me a total of 3,020.8 cubic feet for a single lot. We have 6 lots. So times 6, we have to store a total of 8,125 cubic feet of water. So I'm going to take that number and put it off to the side. We're going to use that in a little bit later. Now I'm going to take a look at lots 7 and 8. 7 and 8. So for the landscape, 0.15 times 38,000 times 5 over 12. So 0.15 times 38,000 times 5 over 12 is equal to 2,375 cubic feet. Then we take a look at the amount going into the house and driveway. It's another 7,000 square feet times 5 over 12. 2916.7 cubic feet plus 2375 is 5291.7 cubic feet. Okay, and we're going to put that off to the side. And the reason we're not figuring out the number of leaching pools yet is when we do community drainage systems, you look at the total amount in there, you don't need to put the individual leaching pools on the individual properties. So lot number 9, that is 52 and 8,000. So for the landscape, we have 0.15 times 52,000 square feet times 5 over 12. And that will be 3250 cubic feet. When we look at the hardscape, the driveway and the house, 1.0 times 8,000 times 5 over 12. So 8,000 times 5 over 12. That will be 3333.3 cubic feet plus 3250, 6,583.3 cubic feet. And again, we'll put that off to the side. 18125 cubic feet plus 5291.7 cubic feet. And I just realized this is actually for 2 lots, so I'm going to add that in twice. 5291.7 cubic feet plus 6583.3 cubic feet plus 7,500 cubic feet for the road. I add those all together. 18125 plus 5291.7 plus 5291.7 plus 6583.3 plus 7,500. That gives me a total of 42,791.7 cubic feet. I'm going to take that total volume, 42,791.7 cubic feet, and divide that by the capacity of a single vertical foot on a 12-foot diameter leaching pool. Okay, that's 100.88 cubic feet per vertical linear foot. Divide 100.88. That gives me a total of 424.18 vertical linear feet. I will take that 424.18 VLF, and I'm going to divide that by the effective depth of the leaching pool. Leaching pools, we always want to take groundwater minus 5 feet, but we don't do that blindly. Since groundwater is at 30 feet, if we subtract 5, that would give you an effective depth of 25 feet. However, and this is a very important point, you don't want to go past 18 feet. And that's why on the homework problem, I said use 18 feet for your effective depth. So divide by 18, and that gives me 23.57 leaching pools. And we can't have a 0.57 leaching pool, so we round it up to 24 full-size leaching pools. So it'll be 24 12-foot diameter by 18-foot effective depth. All right. For those of you who took the leaching pools and did them on a per lot basis, it's not technically incorrect, but when we do look at an entire system, like an entire subdivision, we want to have that broken out where all the water goes into a single collected system. And if you think about in your neighborhood, you don't typically have leaching pools on everybody's property. They're typically going to be isolated in the street, and that means water from the surrounding neighborhood goes into the streets. All right, in addition to designing the cul-de-sac, I also said include in your calculation the answer to design problem 3 from the class videos. Now, as I'm tracking all the videos, more than half the class is not watching the videos. So on your test on Monday or Tuesday, if you do not pass, please do not complain to me. If you're not putting the effort in at this time, I can't force you to do it. All I can do is give you more practice problems. I can meet with you for extra help. but you need to take control of your education a little bit, and please watch those videos. For those of you who are doing the work, and I do know who they are, thank you. It's appreciated that you are going through that. Okay, let's take a look at this solution. So for this problem, we have some landscaped area, some hardscape area, and I want you to solve it, design the drainage system using leaching galleries. So let's look at what our total numbers are going to be. And you might have to review this initial problem. We have a total area of 80 feet by 200 feet. That area will be 80 by 200. That's a total of 16,000 square feet. Of that total area, the area that is landscaped is 5,600, which means the area that is hardscaped, parking lot and building, would be 16,000 minus the 5,600, which leaves us with 10,400 square feet of building and driveway. Now for this one, I said choose your own runoff coefficient. So for landscape, Q equals CIA. An appropriate landscaping number would be 0.1 or even 0.15 if you wanted to go back to the standards from Brookhaven. So let's use 0.1 times the intensity of rain on this. We said was going to be 5 inches of rain, 5 over 12 times 5,600 square feet. So 0.1 times 5 over 12 times 5,600 is 233.3 cubic feet. Then I have Q, oh, that's for the landscaping. Q of the hardscaping would be 100% runoff times 5 over 12 times 10,400. 5 over 12 times 10,400 is 4333.3 cubic feet, which gives me a total volume of 233.3. We need to find storage for 4566.6 cubic feet. Okay, so if we take that total amount, 4566.6 cubic feet, we got to put that into a leaching galley. So leaching galleries are not something that we looked at yet. We haven't talked about the capacity of them, but I did show you on the drainage PowerPoint what they look like, and also I put up a cut sheet for it. And what I was hoping that you were going to do, and some of you did, is you looked a little bit deeper into that cut sheet, and that PDF was also included in the drainage package as kind of a hint to, hey, look this way. It also shows up in the video as well. Let's pull that up to read what it says on here. Okay, everything you need to know is always provided for you. It's just a matter of learning to look and also where to look. So leaching data. Right here, we have a whole bunch of stuff. We have a flow line. We have leaching galley gallons per linear foot. We have square feet per unit. And then here, the inside capacity in gallons. That's the magic number. So I'm going to take that number of 330 gallons, and when I divide that by 330 gallons per unit, I get, forget the number, I get a unit of a cubic foot per gallon per unit. What the heck is that? Doesn't make any sense. You have to go a little bit further. How many cubic feet are there in a gallon? Well, there are 7.48 cubic feet per gallon, I'm sorry, gallons per cubic feet. So that's going to give us a number of, let's see, 330 divide 7.48, 44.11. So 4566.6 cubic feet divided by 44.11 cubic feet per unit. And each unit is a leaching galley. So 4566.6 divide 44.11, 103.52 leaching galleys. Now I can already hear you saying, Professor Simon, how are we supposed to know that we need to look for something? This is your future careers. You need to want to do a little bit more investigating than just what's provided to you. You have to take it that next step forward. You're going to be future architects and future engineers. You're going to be asked to design things. You're going to be asked to solve a lot of problems. You need to start taking those steps now. Okay, so I also have some more problems for you to work on for practice. We'll talk about those in the next video.